So waves are everywhere in our lives. Every ripple in a pool, every earthquake, every sound that you hear when you go running, the way the shock travels up your body from the impact of your feet on the ground is by waves in your bones. Fundamentally, quantum field theory is the deepest theory we know, and that basically says that everything is a wave. And Edie showed us lots of properties of waves, all the basic features. So let's summarize those and then go into some more detail. So a wave is just an oscillation that travels through a medium. And if that medium is made of matter, for example, air or a rock or a guitar string, then we call that a mechanical wave. And most things that we've talked about thus far have been mechanical waves. The movement of a slinky, sound in air, the movement of the earth in an earthquake, the movement of a guitar string, those are all mechanical waves. Indeed, are there other kinds of waves? And the answer is yes. Sometimes the medium doesn't have to be matter. Sometimes, for example, it could be electric or magnetic fields, but we can talk about that more later. One thing that distinguishes a wave from other movement of matter is that the medium itself, on average, doesn't move. So when I talk to someone across the room, I'm not sending air across the room. I'm just simply sending wiggles in the air across the room. And in this way, we can transfer energy via waves. And so I give energy to the air just next to my vocal cords, and that gives energy to the air just next to it, and so forth. And so by making waves in the air, we can transport energy across the room without actually transporting the air across the room. We learned that we often distinguish between different waves depending on which direction the oscillations are. So if you have the oscillations in the direction of the motion of the wave, then that's called a longitudinal wave. And if they go sideways or transverse to the direction of the travel of the wave, then they're called transverse waves.